Hello guys, this is our custom built multi-purpose IoT PCB board designed to power a wide range of smart applications like smart street light, traffic light, greenhouse monitoring, feedback system and much more. At the heart of this board, we have a ESP32 microcontroller and STM32 microcontroller giving the developers and engineers unmatched flexibility to work with the Wi-Fi, Bluetooth, and LoRa communication all on the same platform. Powering the board made it easy with onboard 232 AC to 12 volt DC converter. This make it ideal for field installation without external power adapter. We have included the onboard voltage regulator for 5 volt and 3.3 volt power relay, ensuring a clean, regulated power supply for both logic level sensors and external modules. On the STM32 side, we have integrated a LoRa module. This enables long-range communication, especially useful in applications like smart agriculture, smart street light, and remote data logging. On the ESP32, we get a dual core processing power with a built-in Wi-Fi module and Bluetooth, perfect for cloud communication, mobile app, and local control. In this board features four onboard relays that can control AC or DC loads, whether it turning on a street light, activating irrigation pump, or controlling fans. The relay have you covered. We have exposed all essential I/O for both ESP32 and STM32 on bare connector, including I2C, UART, SPI, and analog and digital pins. This allows plug and play interfacing with sensors like soil moisture, temperature, humidity, CO2 sensor, ultrasonic sensor, touch inputs, display, and more. We have also added a reset and boot buttons for both microcontroller, which helps during firmware uploading, flashing, or manual control. This board is field tested and ready for a deployment. Whether you are startup, researcher, or students, this board can accelerate your smart IoT solution. From smart cities for smart farming, this versatile IoT PCB is perfect foundation for your next innovation.
Hello everyone. This is the code for Smart Feedback System based on ESP32 microcontroller. This system sends feedback to a cloud server using Wi-Fi when one of the three buttons is pressed. The code begins with the four important libraries for Wi-Fi connection, for sending HTTP requests and to connect multiple Wi-Fi networks. The buttons are connected to pins like 21, 22 and 27 representing bad, good and excellent. Each one is set as an input pull-up. Corresponding LEDs or relays are connected to GPIOs 2, 25 and 26 set as output. Next, multiple Wi-Fi networks are added so that the device can connect to any available one. Inside the loop function, the ESP32 constantly checks if Wi-Fi is connected or not. If not, it retries until connected. It then checks if any button is pressed. For example, if the excellent button is pressed, GPIO 26 is turned on to indicate feedback. Then a GET request is sent to the cloud API which is mentioned in the code. The same logic is repeated for the good and the bad buttons. GPIO 25 is used for good and GPIO 2 is for bad. Each sends a unique API request and receives a confirmation response. The cloud server logs each feedback pressed by counting how many times each URL is accessed. This helps in analyzing real time feedback from the users. This is simple yet powerful system connects ESP32 with cloud analytics using just buttons, relays and HTTP protocol. This is the dashboard of our smart feedback system. This dashboard provides real-time insights based on user feedback collected from physical button presses at different locations. At the top, you can see the three separate sections: library, canteen, and classroom. Each card shows feedback results for the specific location. Just below the title, you have a 5-star rating display along with the counter showing how many users have submitted feedback. Since this is a fresh session, it currently shows 0 users for each. To the right of the title, you will find a trend indicator. This shows whether the feedback is improving or declining over time. Each location displays 3 colored bars representing excellent, good, and bad. The bar shows the percentage of responses and the number of users for each category. The more users press a particular button, the wider the bar and the higher the percentage shown. At the bottom of the card, there is a summary section showing the overall user experience in the form of an emoji. This quick This gives a quick visual cue of how people feel about the environment in that location. This dashboard updates in real time whenever a button is pressed in the physical feedback system. All data is fetched from the cloud and instantly reflected here. This smart and initiative interface helps administrators monitor satisfaction and take action where needed. Simple, effective, and live. That's the power of our smart feedback system.
This is IoT-based feedback system. Here we have three modes, that is bad, good and excellent. Whenever the person clicks any button, the data will be fetched to the cloud and it will be shown in our application. This application can be used in hospitals, school and public places.